In this video, we're gonna do some practice on binomial theorem with rational exponents. So let's say we have a question. Write 1 over 1 plus 3x exponent 2 as 1 plus bx plus qx squared plus rx cubed. For sure, because we have rational exponents, we're gonna have infinitely many terms in the expansion. But the question is only write up to x cubed. They might ask it in a different way. Expand up to the fourth term in the expansion. So 1, 2, 3, 4. We can see 4 terms here, so up to x cubed. Now, the first thing, whenever we have a fraction, we cannot use binomial theorem directly. So in this case, we have to take the denominator up, and as we know, whenever we change the place of a number or a factor from the denominator to the numerator, we have to change the sign of the exponent. So we get 1 plus 3x exponent negative 2. As I can notice, we have 1 plus 3x exponent negative 2, and negative 2 here is a rational number. So I need to ask myself this question: is it of the form 1 plus big X exponent n? Yes. So 1 plus big X exponent n. N in this case is negative 2. Big X is 3x. Now, for sure, if we need to use the binomial expansion, we need to know the condition that big X, so this works if and only if the absolute value of big X is smaller than 1. Always use the following rule. Now, let's expand, and then I'm gonna write the condition at the end. So it's equal to nc0, so minus 2c0. Now big X exponent 0, as I said, no need to write it, so let's skip it. Now minus 2c1, big X exponent 1, so big X in this case is 3x exponent 1. Then minus 2c2, big X exponent 2, so 3x exponent 2. And I need to keep going till I reach x cubed. So minus 2c3, 3x exponent 3. For sure, as I said, we have more terms. Now, the first one, you should memorize it. Whenever you have nc0 is directly 1. The second coefficient, nc1, is always n, so we write minus 2 times 3x. Now the minus 2 and minus 2c3, we have to calculate them on the side. So I'm gonna do it here. So minus 2c2, as we said in the previous video, directly we go to the denominator and we write 2 factorial, which is the same number here. And on top we need 2 factors starting with minus 2. And we subtract 1 to get the next one, so minus 2 minus 1. Once we simplify this, we're gonna get positive 3. So I write plus 3, and 3x squared, we need to distribute the square for the 3 and the x, and we get 9x squared. Now, minus 2c3, I write fraction, and down we write 3 factorial. Again, because we have 3, we need 3 factors on top. So starting with minus 2, the next one will be minus 2 minus 1. As we said, we keep subtracting 1. The third factor will be minus 2 minus 2. Now simplifying this, you get minus 2 multiplied by negative 3 multiplied by negative 4. 3 factorial is 1 times 2 times 3, which is 6. Now if you notice, minus 2 times negative 3 is 6. So 6 and 6 will cancel, and my final answer will be negative 4. So I write minus 4, and I distribute the cube for the 3 and for the x. 3 cubed is not 9. So it's not 3 times 3. It's a 3 multiplied by itself 3 times, so it's 27 x cubed. Now, when we simplify this, we get 1 minus 6x plus 27x squared minus 108x cubed. And this is what they're asking you to do. So it looks like 1 plus px plus qx squared plus r x cubed. So if they ask you what is p, in this case you're gonna say it's negative 6. If they ask what is q, it's 27. What is r? It's negative 108. Now you need to pay attention to one thing. If they give you the form in this way, 1 minus px plus qx squared minus rx cubed, if they write for you the minus here and there, so in this case p will be only 6 because the minus is already written, and the r will be only 108 because the minus is written. I hope this was clear. We're gonna do another question. If they tell you expand 2 plus x over 1 plus x as far as the term that has x exponent 4. So in this case, we have fraction, so how can I expand? I cannot. I look at the denominator. Whenever we need to use binomial theorem, we should have the factor is only in the numerator. So 1 plus x is in the denominator. It doesn't have an exponent, it means exponent 1. So my aim is to take it up and multiply it with the numerator. Now when I say multiply it with the numerator, which is 2 plus x in this case. So I rewrite this as 2 plus x multiplied by 1 plus x exponent negative 1, because when you move a factor from the denominator to the numerator, we need to change the sign of the exponent only. Alright, so if I'm doing this, I prefer to take this part alone and do it on the side. So 1 plus x exponent negative 1. I can see we have rational exponent, so I need to check, do I have the form 1 plus big X exponent negative 1 or to the exponent n? Yes. Big X in this case is the same as small x, and n is negative 1. So let's start expanding. Minus 1c0 is the first, no need to write anything next to it. The second term will be minus 1, 1. And big X is the same as small x exponent 1. Then minus 1, 2. Small x exponent 2. Then minus 1, 3. X exponent 3. I keep going till I reach the term with x exponent 4. So minus 1, 4. X exponent 4. Now for sure we have more, but just I need to stop here. Now minus 1c0, we should know that's exactly 1. Now nc1 is n, so in this case n is negative 1. No need to write plus negative 1. Directly you are allowed to write it as negative 1. So minus 1 multiplied by x. Now minus 1c2, we don't know this, so we have to apply the rule. 2 factorial down. On top I start with minus 1, and I need 2 factors, so the second factor will be minus 1, minus 1. So we get minus 1 multiplied by negative 2 over 2 factorial, which is 1 times 2, it's just 2. When we simplify this, my answer will be 1. So this will be positive 1 x squared. Now again, for minus 1c3, I have to do it on the side. So 3 factorial down. On top I start with minus 1, then minus 1, minus 1. I need 3 factors. So we write minus 1, minus 2 for the third factor, and then we simplify this. When we simplify it, my answer will be negative 1. You can use calculator for that. Then minus 1c4, we're gonna use it. So let me write this, minus 1 x cubed. Minus 1c4, I write 4 factorial, and on top I write minus 1. I need 4 factors, starting with minus 1. So minus 1 is the first, this is the second, third, and this is the fourth. Now, when we simplify that one using calculator or manually, we should get positive 1. So plus 1 x exponent 4. Let's finalize the answer. So 1 minus x plus x squared minus x cubed plus x exponent 4. Now we should not stop here. because my aim is to expand 2 plus x over 1 plus x exponent 1, and we rewrote it as 2 plus x multiplied by 1 plus x exponent negative 1. So I will write now 2 plus x, 1 plus x exponent negative 1. Now I'm going to remove this and write the expansion we got. 1 minus x plus x squared minus x cubed plus x exponent 4, and so on. Now, for sure it works only if the absolute value of x is smaller than 1. And in this case, absolute value of x smaller than 1, it means absolute value of small x is smaller than 1. So x is between 1 and negative 1. So this expansion works if we have the following. Now, we continue. I have to distribute the 2. So we get 2 minus 2x plus 2x squared minus 2x cubed plus 2x exponent 4. Then we have to distribute the x for all of them. And we get plus x. X times x is x squared, so minus x squared, plus x cubed minus x exponent 4 plus x exponent 5. And we have more. Alright, so our final step is to simplify. I check, do I have similar term to 2? Do I have any other constant number? No, we have only 2. Do I have any similar term to minus 2x? Yes, the term that has x is only plus x on the other side. So minus 2x plus x will be minus x. Then we look at x squared. I have 1 here. So plus 2x squared minus x squared will be plus x squared. Now I look at x cubed. We have minus 2x cubed plus x cubed, and it will be minus x cubed. We look at 2 exponent 4 and minus x exponent 4, and we have plus x exponent 4. I can stop here, no need for the x exponent 5, because in the question as far as x exponent 4. So this will be the expansion up to x exponent 4. I hope this was clear, and let's do one more example. So if we have in number 3, they're telling you in part A, expand the fourth root of 16 plus 6x as far as x squared. Now, before we start with this question, you need to remember as a note that whenever we have nth root of anything exponent m, this can be written as the factor exponent m divided by n. The one inside, we divided by the index of the root. Now, so in part A, they said just expand. To apply the binomial theorem, we should not have a root. So I'm gonna rewrite this as inside we have no exponent, it means exponent 1, so it becomes 1 over 4, and this will become 16 plus 6x. So let's expand this one. First of all, I can notice that we have rational exponent. Now, if I have rational exponent, I need the form 1 plus big X exponent n, but I don't have that form. Let's change 16 plus 6x exponent 1 over 4 to the form 1 plus big X exponent n. How can I do this? You keep the exponent 1 over 4, and then I want the 16 to turn to 1, so I have to take 16 as a common factor. So whatever the number here is, you need to take it as a common factor always. So you take 16 as a common factor, then you do 16 divided by 16, it will be 1, plus 6x divided by 16, it will be 6 over 16 x. My next step is to distribute the exponent 1 over 4 to 16 and to the factor. So I will write 16 exponent 1 over 4, and here there is a common mistake where many students, they do 16 times 1 over 4 and they write it as 4, and this is actually wrong. The correct thing here is to do the fourth root of 16, and it's gonna be 2. Now 1 plus, for sure it's better to simplify the 6 over 16, so divide by 2 by 2, you get 3 over 8 x exponent 1 over 4. Alright, as I said, this is 2, and this is 1 plus 3 over 8 x exponent 1 over 4. Let's expand this. So the 2 stays 2, and I'm gonna expand inside the bracket. Alright, so I'm gonna start NC0, which is 1 over 4 C0 plus 1 over 4 C1, and big X in this case is 3 over 8 x exponent 1 plus 1 over 4 C2 3 over 8 x exponent 2. I can stop here because they said as far as x squared. Now, for sure, if we're talking about the expansion, again, I should have absolute value of big X smaller than 1, which is in this case absolute value of 3 over 8x smaller than 1. Now I'm going to simplify it after we finalize this answer. So 2 bracket. The first one, NC0, is always 1. The second one, NC1, is always n. In this case, it's positive 1 over 4, multiplied by 3 over 8x. Now 1 over 4 C2, we don't know, so I will write it here, then I will erase it after. So I write 2 factorial down. On top we have 1 over 4 multiplied by 1 over 4 minus 1. And we did this question actually before in a previous video. So this is minus 3 over 4, and 2 factorial is just 2. My answer will be minus 3 over 16 over 2, which is minus 3 over 32. So I will write now, instead of 1 over 4 C2, I will write minus 3 over 32. Now the square, we need to distribute it for the 3, for the x, and for the 8. So it becomes 9 over 64 x squared. Now we have to distribute the 2. If you want to simplify the one inside the bracket first, then distribute the 2, that's totally fine. So 1 plus 3 over 32x minus 27 over, when you multiply 32 by 64, it's gonna be 2048 x squared. And now we can distribute the 2, so we get 2 plus, then you do 2 times 3 over 32, it will be 3 over 16. And when you do 2 multiplied by negative 27 over 2048, it will be 1024 x squared. So we have more terms. Now going back to the condition, I have 3 over 8x in absolute value smaller than 1. Whenever you have a constant number, no need to keep it in absolute value, because that can be written in this way. So you can separate the absolute value, and then absolute value of 3 over 8 is just 3 over 8. Absolute value of x is smaller than 1. Then to remove the 3 over 8, you can multiply by its reciprocal. So 8 and 8 will cancel, 3 and 3 will cancel. But for sure, if you multiply on the left side by 8 over 3, you should do the same on the other side. Now, absolute value of x will be smaller than 8 over 3. It means, going back to the rule I explained before, you write x is smaller than 8 over 3 and same number on the other side with a negative sign. So this is our condition. Now, they might add a part to this question and they ask, estimate, or using part A, using A, estimate the fourth root of 22. Now, in this case, I need to use part A. In part A, we had fourth root of 16 plus 2x at the beginning. So we go back to the main one. It was 16 plus 6x inside the fourth root. So I will write 16 plus 6x and the fourth root of that. Now, I want this to be 22. So I will write 16 plus 6x equals 22, and let's check which x value will give me 22 inside the fourth root. So subtract 6 on both sides, or just take the 16 to the other side. It becomes negative 16, so 22 minus 16, which is 6, and we get x equals 1. So basically, the fourth root of 22 is the same thing as fourth root of 16 plus 6 multiplied by 1. So when you substitute x in the expansion by 1, you will get the estimation of fourth root of 22. Now we know the expansion of fourth root of 16 plus 6x, which is the one here. So I can go back because it's estimation, so I'm gonna write it's approximately equal to 2 plus 3 over 16 multiplied by 1 minus 27 over 1024 1 squared, which is approximately, you can use calculator for this, and it becomes 2.161. Now I wrote it up to 3 decimal places. Or they might ask you for significant figures. So 3 decimal places in this case is the same as 4 significant figures. Now they might ask one more thing, which is calculate using calculator and estimate to 4 significant figures or 3 decimal places the exact answer. So when you do it on the calculator, it will be 2.165. So this is exact. So this is the estimation using calculator actually. I'm not gonna call it exact. So using calculator. Now, in part D, they might ask you what is the difference between the estimation we did in part B and the estimation we did using calculator. In this case, you're gonna subtract. You can use you can use absolute value, and you do 2.165 minus 2.161. And the answer of this, when you do it, will be absolute value of 0.004, which is only 0.004. Or if you can do directly the bigger number minus the smaller number, no need to use absolute value. If they ask you as a fraction, you write 1 over 250. I hope this was clear, and I will do one more video, some practices on binomial theorem.